Before we get into why you want to use specific colors, let's take a little look at the history of color. Interestingly enough, color was originally described not as RGB like we see it today, but as RYB. Color theory was originally formulated in terms of three primary or primitive colors: red, yellow, and blue, hence RYB. Because these colors were believed to be capable of mixing all other colors, the RYB primary colors became the foundation of 18th century theories of color vision, and they served as the fundamental sensory qualities that are blended in the perception of all physical colors and equally in the physical mixture of pigments or dyes. During the late 19th century, it was determined that color perception is best described in terms of a different set of primary colors: red, green, and blue, or blue-violet, and that's where we get our standard RGB that we use today. These were modeled through the additive mixture, and they used the three monochromatic lights. The first color wheel was invented by Sir Isaac Newton. He split white sunlight into red, orange, yellow, green, cyan, and blue beams, and then he joined the two ends of the color spectrum together to show the natural progression of colors. Newton associated each color with a note on a musical scale. A century after Newton, Johann Wolfgang Goethe began studying psychological effects of color. He noticed that blue gives a feeling of coolness and yellow has a warming effect. Goethe created a color wheel showing the psychological effect of each color. He divided all the colors into two groups: the plus side, which ranged from red through orange to yellow, that would be located right here, and the minus side, from green through violet to blue. Colors of the plus side produced excitement and cheerfulness. Colors of the minus side are associated with weakness and unsettled feelings. A current form of color theory was developed by Johannes Itten, a Swiss color and art theorist. This school is also known as the Bauhaus School. Itten developed color chords and modified the color wheel. Etten's color wheel is based on red, yellow, and blue colors as the primary triad that includes 12 hues. This is the color wheel that we basically use today. For a long time now, there's been a problem that fledgling or newbie designers have run into on a constant basis. This problem seems insignificant to most, but in actuality it's quite possibly the most important factor in design or a piece of artwork. Yes, you guessed it. I'm talking about the issue of color. How can you decide what color to use? Color can definitely be a touchy subject. Sometimes artists use colors that evoke certain emotions. Other times artists use colors simply because they just like the way they look. Color always has meaning. This meaning can be an emotional one, or it can be a personal preference on the part of the artist himself or herself, but it always has some sort of purpose behind it. There's nothing wrong with choosing a color simply because you like it. After all, it is your work. But when choosing a color, you still want to make sure that its use does not conflict with what you're trying to say with your work. Proper use of basic color theory can help you decide what colors match, as well as how each color makes people feel. Color is the perceptual characteristic of light described by a color name. Specifically, color is light, and light is composed of many colors. Those we see are the colors of the visual spectrum: red, orange, yellow, green, blue, and violet. Objects absorb certain wavelengths and reflect others back to the viewer. We perceive the wavelengths as color. A color is described in three ways: by its name, how pure or desaturated it is, and its value or lightness. Although pink or brick or bright red are all variations of the color red, each hue is distinct and differentiated by its chroma, saturation, intensity, and value. Chroma, intensity, saturation, luminescence, and value are interrelated terms that have to do with the description of color. So let's just define each of these. Chroma is basically how pure a hue is in relationship to gray. Saturation is the degree of purity of a hue. Intensity is the brightness or dullness of a hue. One may lower the intensity by adding white or black. Luminescence or value is a measure of the amount of light reflected from a hue. Hues with high content of white have a higher luminescence or value. Shade and tint are terms that refer to the variation of a hue. And shade is basically a hue that's produced by the addition of black, and tint is a hue that's produced by the addition of white. So these are some basic terms that we'll be using as we go through and talk more about color. So just make sure you're comfortable with them and you understand their meanings. There's two main color systems that you'll probably come across when you're designing. They are CMYK, which stands for cyan, magenta, yellow, and black. And available color systems are dependent on the medium with which a designer is working. When someone is painting, an artist has a variety of paints to choose from, and mixed colors are achieved through the subtractive color method. When a designer is utilizing the computer to generate digital media, colors are achieved with the additive color method. So the subtractive color method is when we mix colors using paint or through a printing process. We are using the subtractive color method in that situation as well. Subtractive color simply means that one begins with white and ends with black. So as one adds color, the result gets darker and tends to go towards black eventually. And you can kind of see that happening here. As we add more colors on top of each other, we start to get the darkest color in the center right here. The CMYK, which as I mentioned is short for cyan, magenta, yellow, and actually key, that's what the K stands for. Key is basically black, is often referred to as process color or four-color. And this particular color model works by the subtractive or reflective color. Reflective color represents energy that is not absorbed by a substance such as ink or paint. Pigments and CMYK color work the way color does in nature, according to the subtractive color model. Sunlight contains every visible color, and when sunlight is projected onto an object, the object absorbs or subtracts some of the light and reflects the remainder. The reflected light is the visible color. So if I'm looking at a sunflower, the sunflower is yellow because it absorbs all of the non-yellow light from the light spectrum and it reflects the yellow back to me. Additive color model is the other color model, and if you're working on a computer, the colors that you see on the screen are created with light using the additive color method. Additive color mixing begins with black and ends with white. So as more color is added, the result becomes lighter and tends to be towards white. And you can see that happening in this diagram right here. The additive or radiant color system is used by RGB color. Radiant color is produced by the energy radiated from a luminescent object, such as a computer monitor, which is basically a cathode ray tube or light emitting diode. And all computer monitors have these things inside them. RGB is called additive because a color becomes lighter as higher levels of red, green, and blue light are added. The visible spectrum consists of billions of colors. A monitor can display millions, and a high-quality printer is only capable of producing thousands. So reproducing color can be problematic with regard to printing digital media because what we see is not what it is actually possible to get. Although a monitor may be able to display true color, which is basically 16 million colors, millions of these colors are outside the spectrum available to printers. Since digital designs are generated using the RGB color system, colors used in those designs must be part of the CMYK spectrum or they will not be reproduced with the proper color rendering. Working within the CMYK color system or choosing colors from the Pantone palettes is going to ensure proper color rendering. So I just want you to be aware of the different color systems and how they are used, because obviously it's going to affect your end result in your designs.